All right, happy day, guys. More math. So we're going to be talking about special cases. Now, this is something that you guys have probably seen the most repeated throughout the year as we've gone through and done factoring, because this is basically what we have to work towards when we are doing completing the square, right? We're trying to get these down to a specific format, and if we have a perfect square situation, then we can quickly format a lot of these down. So when we're looking at these setups, we're assuming that these two numbers are perfect squares, meaning that when I square root them, I get a nice number and not a decimal or a radical of some kind. Okay, so the A and the C are perfect squares. If those are perfect squares, then they'll factor down in a specific way every time. Now, you could always, if you have a trinomial like this, you could split this middle term in two and then factor by grouping like you normally did. But when we split it by 2, we have to divide it by 2, right? Well, if we take B and we divide it by 2, and then that'll tell me what the number is that I would get when I square C, right? In fact, I could just square root. If I square root C, I should get this B if it's a perfect square. Okay? And then the A, if you square root that, this is always going to come down to when we actually factor it, we're going to get the square root of ax squared, which is just the square root of a times x. In fact, let's take that out. Let me rewrite that. We'll get the square root of a times x, and then depending on which sign is next to the b, you would get a plus or a minus the b term divided by 2 squared. Okay, you'll get that every time. Every time. Okay, and again, C should just be the b divided by 2 squared every time. That's the pattern you'll get here. Over here, when we have the difference between two perfect squares, right, you're going to get something similar, but you're going to end up with a binomial instead. Well, I mean, this is technically a binomial as well. But when you have a difference, that means that this middle term, this b, basically canceled out. That means b went to 0. Okay? So let's set this up, and I'll show you how this should look whenever you actually finally solve it. So what you should get when you factor this out is you'd get the square root of a times x, and then plus the square root of c, and that would multiply with the square root of a times x minus the square root of c. Okay, every time. So let's see if we can figure this out. So let's look at an example here. So we have x squared plus 10x plus 25. This matches this setup right here, right? The number in front of x would be a 1, right? Is that a perfect square? 1 squared is 1. Square root of 1 is 1. Yep, it's a perfect square. Okay, and when it's 1, you don't really have to worry about it because 1 goes away when you multiply. So it does have a perfect square there. 25, is that a perfect square? Yeah, you can square root it, get 5. Okay, now let's double check. If I take the middle term divided by 2, do I get the square root of c? So 25 square root of that is 5. Yep. So what this is going to come down to would be, and here I'll do a long way of doing it, and then I'll do a short way. The short way, I can just tell that the special case is going to be the square root of a, which is 1, times x, and then it'll be plus 5 since the b is plus, and then we would square that. That's going to be my answer. Now I'm going to try splitting this middle term into 2 parts, and then we'll try factor by grouping and see if we get the same answer. So if I get x squared plus 5x, and then plus 5x plus 25. Okay, so this first one I can take out an x. I'll write it down here. So x times x plus 5 This second one I can take out a 5, so plus 5 times x plus 5. Hey, look, I can factor out an x plus 5. And then I would get x plus 5. Hey, I can also write that as x plus 5 squared. Great. So either way you're doing it, you're going to get the same answer, but if you can recognize the pattern, it saves a lot of time and work, right? So let's try another one, a little bit more difficult. So this one, 9, is 9 a perfect square? Well, the square root of 9 is 3, so yeah, that's a perfect square. 1 is 1 a perfect square? Well, square root of 1 is 1. So, yep. Now, this one, because a is different, it's not going to be the b squared. It's going to be, it's still going to be the square root of 1, so it'll just be 1 there. The reason is when we square root this, it's going to change this term, and you'll see. So, in fact, I should rewrite this. Instead of being b squared, I should write that as square root of c, because that is more true. Okay. So I'm going to break it down and do the quick form. So square root of 9 is 3, right? So I should get 3k square root of 1 is 1 plus 1 squared when I'm done. Now I'm just going to double check this, make sure it works. I won't do this on all of them, but I just want to double check and make sure this works. So I would split this middle term into 2. So I'd have 9k to the second plus 3k plus 3k plus 1. Okay, and then factor by grouping, I could take out a 3k out of this first one, I'll be left with k plus 1. And then I can take out nothing, a 1, technically in this second one, so plus 1, which doesn't really change anything. But I still need to take out that 1, because when I factor out, this was a 3k right here. When I factor out this 3k, I need to be left with 3k plus 1. Because that second parentheses isn't going to just magically be there. If I wanted to distribute that 3k plus 1, it needs something to multiply with. Okay, so you see we get the same thing. Okay, that's the last time I'm going to do the factor by grouping. Let's look at a difference between... should I do a factor? No, you guys can get it. Basically, you'd have a positive and a negative b when you distribute, so they would cancel out when you set it up like this. So first of all, we check to see if a is a perfect square. It has a coefficient of 1, so yep, perfect square. 100 perfect square, yep. Square root of 100 is 10. So what this is going to end up coming down to is going to be a plus 10 multiplying with a minus 10. Right? Square root of a times the variable, and then plus the square root of c, plus or minus the square root of c. Okay? And then the other perfect square, so a is 25, the square root of that is 5, so that works. 16, square root of that is 4, so that works. So I can split it up, and it would be 5x plus 4 times 5x minus 4. So let's prove this and make sure it works, because I haven't proved it on these types yet. I know this is going kind of long, but let's prove it. So again, let's try distributing this time. So I'm going to distribute the 5x, and I'm going to distribute the 4. I'm going to do this very quickly. So 5 times 5x is 25x squared. 5 times negative 4 is negative 20x. 4 times 5 is 20x. 4 times negative 4 is negative 16. Combine those, we get 0. I'm left with 25x squared minus 16. Hey, it's the same equation. So, yep, that was my answer right there. Yep, that is special cases.